Hello everyone, I hope that you are hearing me. If not, please send a message in the chat. I'm checking the chat in my side, right? So you may see me looking a bit. Hello Fred, I see some, yeah, most of the presentation was based on Krunau's work, so I hope he likes it. I also put some links from his blog as well. So welcome everyone. I'm really happy to be here again. This time, even if an online event, Percona Live has a very special personal feeling for me. It was my first international conference, so it means for me. And today we are going to start, today we are going to talk about MySQL, how it behaves on ARM when we are comparing to the classic platforms, x86 on Intel or AMD, whatever. And I must say I got very interesting results that I was not expecting. And of course, during the way, I found some problems, which I will share with you. And I hope that after this presentation, you can get out with a more clear sight of ARM architecture, and if you have plans to migrate, if it helps you some way. So, a little bit about me. I am a Percona engineer for around 4 years already. And I've been working with database for 12 years. I started with SQL Server. Then in the last 6 years, I migrated to open source. So it's basically this. I had the chance to be around in some conference where I have the chance to see Fred, Valeri, Shlomi, all these monsters of MySQL. So it's good to be here. First, let's do a small introduction. I know that many of you might be aware, but what is ARM when we are comparing to x86? So ARM have reduced the instructions, has reduced these instructions when compared to x86. This means that the instructions in ARM, they are smaller in size, and they usually process in a fast rate, because, well, if they are smaller, you have to spend less CPU cycles to process. It has a very high power efficiency. For example, the latest Apple M1 chip has 10 watts of TDP, the thermal design power. And from what I saw, TDP from a Core i9, of course it varies depending if you're overclocking, whatever, but it's around 160. So it's a very huge difference, which can make a significant impact on the budget. So another reason that ARM is very famous because it's affordable. It's easy to produce compared to x86. So that's why we see ARM being used on the cheapest cell phones equipment from the most expensive ones. So there is a wide area that ARM can benefit from and have been benefiting for a long time. The most classic examples of ARM currently, of course, it's the Apple M1 chip, which is based on ARM v86 8.6 architecture. And from cloud perspective, I didn't search for others, but Graviton in AWS are instances based on ARM. So what is the difference when we are talking about x86? x86 have complex instructions, which means that when we compare to ARM, let's say we can get 3 ARM instructions and put everything together in a single CISC instruction. The idea is to reduce the number of instructions and make the process faster. What is the big difference between the two platforms? When you are coding for ARM, you need to optimize a lot your code, because most of the optimization needs to be done by the application. And when we migrate to x86, these complex tasks usually goes to the hardware. So it's kind of opposite both, and it really depends on your approach. As we can see, for example, the Big Sur from Apple, it runs really smooth on their platform, while we saw the Windows ARM on some device around which the performance was not even close or not even desired, right? And the classic companies are Intel and AMD. Let's start. We'll go through how I did the benchmark. So if you guys have any questions, I will be happy to answer. First, what are the machines that I picked? So for x86, I picked M5G 8x large, and for ARM, M6GD 8x large. Both have the same amount of memory and CPUs, and the disks, they are relatively about the same number of IOPS. I also took care to do not make my benchmark tests IO bounded, because I want to focus on the CPU. So I set my InnoDB buffer pool to fit my data set. And many may ask, what is the comparison here? So the comparison is between the same number of CPUs. Many may say like, okay, ARM is 50% cheaper, so it should have 50% more cores. I'm not doing a dollar comparison, but a CPU comparison, okay? Just to make it clear. Both operating systems using CentOS, of course, that one dedicated for ARM and the one dedicated for x86. A bit of the costs, as we can see here, the x86, it's a bit more expensive compared to ARM, as expected. And here is a year report. So if like ARM is 25% cheaper when we use this hour, and of course, if we move to month or year, it will be the same 25% cheaper. If we put 1 month here, x86, it's 1,300, ARM is around 1,000. So the difference is almost $265, which results in a difference of $3,000 per year if you run these machines continuously on cloud. So for those who are managers or trying to measure the impact in the budget, this is somehow the math that you are going to end up doing. And I did here a small math, like a small count of how much it costs one CPU ready for 1 month. So again, $41 for x86, $32 for ARM. These are my configuration file that I used. As you can see, 100 gigs. As I said, I want to fit my entire data set in memory. I didn't want MySQL struggling with writes, so I resized the log file size, and I made the writes to the binary log asynchronous on both environments. And at the moment that I did the tests, I was using MySQL Community 8023 for both. I know it is available 24 already, so, but I believe the performance is not going to change that much. I used Sysbench to perform the tests. So I created one separated machine from my environment only to run Sysbench because in this case, I didn't want the own sysbench workload interfering in my results. And also because it's really hard to make sysbench working on ARM platform. So it is, I found it easier to put on a dedicated server and just fire the commands to the database. I used tpcc like workload, OLTP, and OLTP read-only. And we will cover all these three results. So yeah, as yesterday, as per Marcel and Frederick, we are on 8.025 already. So yeah, we are moving fast. My tests I run with 8, 16, 32, 64, and until 25.6 threads. So I want to measure the performance under a low load, medium load, when the CPUs are close to 100% and when they are saturated. And what were the results that I obtained? Let's start with tpcc. So here, as we can see, on my left, on your left, we have ARM, and on the right, we have x86. And for almost all of this, ARM performed better. As you can see here, we have transactions and we have queries. I'm compare, of course, transactions with transactions, queries with queries, to make sure that bananas and apples are the same. Transactions, of course, involves more, it can contain 1 to n queries, and queries are single execution. If I put this in a nice way, in a dashboard, this is what I got. So as we can see, the orange bar is ARM, the green one is x86. The only time that, no, it was not here. The only time that x86 performed here was with 128 threads. One thing just to make clear, when I prepared the data set, I ran sysbench on both platforms twice. I discarded these results to avoid code buffer cache issues, anything like that. So the first 2 runs, I just made it to ARM MySQL and discarded them. And as we can see, only on one specific case that x86 went better than ARM. If we go to queries, we see the same. It's a significant difference in most of the time. Apart from 8 threads, the other ones has a large margin difference. And if we take a look at PMM, note this is a dashboard of ARM. As we can see here, MySQL ARM top command queries. We can see that under certain periods, we are crossing the 100K command counters. If we go to x86, we never get close, right? So this is a significant point. Guys, if you have any questions, feel free to do on the chat. I will be reading here. If it's something during the current slide, maybe I think it's better to answer so we don't need to go back. What were the results that I got when I was running all LTP with reads and writes? So for this case, again, ARM performed better compared to x86. We will see here why I didn't put information here. I didn't forget, there is a reason, which I will explain the next slides. And if we put this in a nice way, we can see ARM performing better in most of the situations. This was not what I was expecting. I was expecting, okay, 25% cheaper, 20% less performance, so I will gain 5% in budget, something like that. But the crazy thing here is that ARM is cheaper and run faster. So like, it is amazing. I think it's the best of the worlds. We save energy, we save money, and the users get faster performance. But there are some tricks. What are you referring to, microarchitecture, Sergio? I use the Graphton instance. Okay. I need to get the type of processors that the instance that I used. I need to get the type of M5D on AWS. What exactly is the processor there? I forgot to get this metric for you, but I can give you later. So these are the results about read-only. And again, I couldn't run 512 threads, but most of the time, ARM performed better. Same for queries, as we expected. So as we can see here, there is a big difference on while we are increasing the number of threads, and the value is somehow smaller or more similar when we are running low workloads. If we go to PMM to monitor this, I can see again ARM here. I'm performing crossing the 300K thresholds for the last 2 runs, while if we go to x86, we never get close to 300. So, and for me, it seems like this last column is getting smaller. So I would say the line is doing like it's reaching a peak and will start to drop. So that's what I got from here. ARM instance only in a single NUMA socket. Yes, it is. It is AWS, so the NUMA architecture was not enabled. And in this case, if we have a NUMA architecture, independent of the platform, you can use InnoDB NUMA interleave to make a fair allocation of memory between among the sockets if you have more than 2. So there are ways to still make this comparison fair. So if both were using NUMA, you would apply these on both. And thanks for the information, Sergio, about the Skylake. So yes, it seems that they are old processors. Maybe if I have chosen a more modern instance, probably they would cost more, but I would have better performance. Moving on, what were the problems that I faced? There are a few problems when we decided to use ARM, and some of them you can fix by yourself. It takes some work to do it. Krunal wrote some blog posts about it. Some of them I couldn't overcome, and some of them I haven't checked, so let's see them. The first problem, as you guys remember from the last slides, on OLTP, I was not able to run 512 threads for ARM. And the reason is that my instance ran out of memory. And I checked x86. x86 was handling everything perfectly, no memory leak, everything running fine. And for some reason, I was not able to do anything on the ARM instance until I restart it. I didn't want to run the tests with 500 after restarting because I think it wouldn't there because, well, the instance is stopped for a reason while x86 continued to deliver the workload. It was stable. So this is a point of attention. It is something to pay attention in the future regarding stability. And what about ecosystem? If I decide to move to ARM environment, ARM ecosystem, what are the problems and what are the tools that I have available from the system? And here is where the things start to get a bit problematic for me at this moment. For those who use Percona binaries, there is no ARM version for it. I've been trying to convince the developers to do that, including MySQL on the list. We don't have extra backup. We don't have Percona toolkit. We don't have PMM client and PMM server. So there are some challenges to overcome. So, given the challenge, I tried to check how it behaved, and I was able to compile Percona extra ARM for Ubuntu and CentOS. One interesting thing here is Oracle does not provide ARM packages for Ubuntu. I opened the feature request for them, which was already accepted. So we have only Red Hat-like binaries available, or you need to compile from source. With also I tested that, but this is not the topic of this presentation, and I personally don't to run custom builds on production. The other issue that I had was with PMM agent. So I was able to compile and reach until a certain point. So I was able to configure the exporters, but I don't know why. And this is probably the lack of my knowledge regarding. I could not fetch MySQL metrics, only operating system metrics. So if you are MySQL on ARM, maybe you will have problems with PMM agent. What was the solution? So here it's a proof of a version that I compiled for Arch Linux 64 bits for 8023. And I remember now the reason that I picked 8023 is to make extra backup. I tested extra backup on both. Of course, it worked on x86 as expected, but it worked really nice as well. I didn't see any problems. I ran 3 times the full backup, and I didn't run into any issues with extra backup on ARM. And I didn't find it that hard to compile compared to PMM agent or even MySQL that has much more flags and required packages to install. I also wrote a blog. The link here, it is wrong. I will fix it. So if you're interested about compiling stuff for ARM, this blog post will teach you how to compile extra backup, and also has a link to compile MySQL for ARM as well. Once you get the recipe, it's somehow let's say easy. Maybe easy is not the correct word, but it is achievable. How I made it work with PMM monitoring system. as we can see here, I'm monitoring, but what I have to do, and the idea didn't come for me at that time, it took me a while, was adding the MySQL ARM as a remote monitoring. So PMM server would connect to the server, collect the metric, and populate Grafana for me. And how you do that? You need to use the add instance option. I will show the picture where you do this. And again, like I had to install so many to compile PMM. And the reason that I do not recommend is, let's say you have a bad employee on your company, he's trying to do something dirty, he can get some code paste on the server and make it run. So that's one of the reasons that we don't left compilers in database production systems. If you have plans to do that, create a dedicated server, compile, and grab the binaries and move to your production server. I think it's the best way to do that. Regarding Michael, the number of, okay, I see what you mean. Like if we have 32 CPUs showed on AWS for x86, probably there are 16 cores running, while for ARM, this relation is 1 by 1. So we have 32. I didn't went that deep. I didn't go that deep. Again, my focus was like trying to compare one CPU with another, one CPU capacity, and see, given the price, if I am a customer, if I pick up this instance and pick ARM instance, how much I will save, how much performance I will have. Of course, there are variations. Again, like as Sergio mentioned, like the Skylake architecture is a bit old. Maybe more modern architecture, x86 architecture, it will run much more closer or even surpass ARM. Here is how to add. If you have plans to add any remote instance, you just click on Services, PMM Add Instance, and voila. The server is, PMM gets the server metrics and starts populating for you. You just need to supply the basic port, username, password, and it goes. You don't have to install any agent. The problem is that you can't fetch operating system metrics, of course, because there is not an agent there, and we are connected to the database, so we can only get database metrics. That there are advantages and disadvantages for everything in computer science. And what was my conclusion of all of this experience that I had with ARM? What I could see and what you guys could see. First, ARM is winning is beating x86 in all workloads type, tpcc, read-only, and OLTP, and it is being 25% cheaper. So many may conclude that, okay, let's move to ARM. It's cheaper, it runs faster, I don't have any problems with that, I will go to ARM. But reality is, it's not like this. These are the tests for read-only. And what are the problems that I could observe? Like, ARM is still a young platform, a young architecture in terms of course, the database world, the MySQL world. It exists much before that, but we are talking specific about this. So we are still lacking some tools. I'm pushing Roma, which he is a developer of PMM team. And if you guys like it, please start pestering on our forums and open Jira request for this. So help me to make him change his mind. And it does not have default packages at the ARM for Ubuntu when we are talking about Oracle. And Percona does not have ARM binaries for any platform at the moment. The only alternative is compiling from source. I don't recall MariaDB. I saw that someone is already using MariaDB on ARM for a long time. Maybe Valerie can also inform us here if Maria has ARM packages, because I honestly don't know. And when we compare to x86, again, what we can see in the future? Well, the platform, as we said, the guys here told, the processor that I was using was from 4 or 5 years old architecture when compared to the most new ARM architecture. Even if equivalent in number of CPUs, they have different performance. Of course, x86 is improving year by year. We know that. So still, there is a long way before the industry decides to move out from x86. The other huge benefit is that the number of tools that we have available for x86. We have the entire Percona ecosystem. We have, if we go to Maria, again, I don't remember if we have ARM, but if you go to Maria, we have not only the database, but the backup. We have monitoring that are on the market already for years, like PMM from Percona, Vivid Cortex, Datadog. So we have many tools like and orchestrator from Shlomi. So if you want to plan a high availability infrastructure, you might find some issues with that. The conclusion that I personally got is, and being straight to the point, like if someone comes to me and say, look, Vinicius, do you think we need to move to ARM to save money? At this moment, I would say no, because of the issues that I had. But of course, I would tell you to start testing, because I think that in the really near future, we are going to find much more stable releases, much more tools available until we can make production decision. At this moment, I would say stay in your QA stage environment, do your tests, and only after that you think about moving to ARM. I know that I think there is one guy here, I think, I don't remember, but he's using ARM for 3 years. I would like to know if he was using production staging. It would be interesting to hear his story. Here are the references that I had to reach this point. So to compile PMM, I want to thank Guli that helped me with that. He left the recipe on his GitHub, and it's very straightforward. The blog about compiling PMM client in ARM. Of course, that if you are interested in ARM, you need to follow Krunal. He's leading that. His blog has excellent articles. They are really nice. I used a few of them to make this presentation. and I highly recommend it. If we and if you are interested about compiling extra batch, the blog post is here. And for those that has more than one database in there, we have a blog post about Postgres that my colleague Sergey he wrote with, by the way, are equal his instance. I try to make everything close to, and they got some very interesting results there as well. And basically that's it. I think I'm ending a few minutes before what I was expecting. On my tests I went much more slower. So guys, do you have any questions? Anything that was not clear that I can help? Just left the message on the chat. I will stay here a few more minutes. I'll give you a minute or so if you have any questions. Yeah, guys. Okay, thanks, Michael, for the information regarding AWS Gravitron. And thanks, Sergio, for the information about the Skylake. So that's it. Hello, Dieter. Miss you guys. I hope we can meet soon in some conference around the world. If you have any questions, please reach me out. It was a huge pleasure. I hope you can get out from here at least with some ideas and with some questions. Of course, it will be nice. Anyone doesn't need to agree with me. On the opposite, I like to hear ideas different from mine. I think that's how we grow together. That's it. Thanks, everyone, and see you next time.